This is the screencast for Lesson 26 in Stephen's C# 24-hour trainer. In this try it, we're going to overload some simple plus, minus, and times operators for the complex number class so we can perform calculations in a slightly more intuitive way than the way we're doing it right now. If we look in here inside the complex number class, we've got these methods, add to, multiply by, and down here subtract from, that take one complex number and perform some calculation with another. So for example, in add to, what we're doing is we're taking the instance of the complex number class that is running the code and we're adding this other complex number to it. Well, that works, and it's a perfectly fine way to do things, but it makes calculations kind of cumbersome. For example, over here in the main form, we perform some calculations. Instead of saying a plus b, we have to say a dot add to b. And instead of saying a minus b, we actually have to say b dot subtract from a. So not only is that a little bit awkward because we're using a method when really it'd be nice to use a minus sign, but it's also awkward because we have to put b on the left here to subtract it from a. So what we're going to do is replace those methods with operator overloads. So let's start with the add method. So I'm going to say public static, all operator overloads have to be static. Complex number, that's the return type of this operator. Operator plus, so that tells it we're overloading the plus operator. And then now the parameters. This version of plus is the binary plus, so it's adding two numbers together. So it's got two parameters. In this case, they're both complex numbers. I like to call these me and other to remind me that there are two different numbers and that I'm thinking of one is on the left, that's going to be the me operator, the me number, and the other is on the right side of the plus sign, that's other. You can name them whatever you like, C1 and C2 if you want to. Now the calculation is pretty much the same as it is in this add to method. All we're really doing is replacing that method with this operator overload, so they should be performing the same calculation. The only other difference is that in this method we have this, which is the instance of the object that's running, and with a static method there is no instance because the method is implemented by the class, so this operator doesn't have a this floating around that we can use. Instead it uses me and other. So I'll just replace the use of this to me, and C1 I'm going to call other, and that's it. So now this operator should be good to go. Now we also overloaded a version of add to that took a double as a parameter, so you could add a complex number to a double. Let's do the same thing with the plus operator. It's going to be pretty similar to this version, so I'm going to start with that. I'll just copy and paste it. However, instead of this second argument being an operator, it's a double. I'm going to change its name to x to remind me that this is a double and not an object. So now how do we need to modify the code? Well, doubles don't have real and imaginary parts. They are the real part, and there is no imaginary part. So this other dot imaginary would be 0 for a double. So we'll just take that out. And you can see down here that agrees with this code. This dot real plus x, and then this dot imaginary. So there's our plus operators. I'm going to copy and paste that code to give me a starting point for our multiplication operators. So I'll change this to times and this to times. The calculation is different, so I'm going to steal the calculation code from the multiply by method we wrote before. And then we have to make the same replacements we did before. So this becomes me and C1 becomes other. So we'll just change that to me, other, other, me, other, other. And if you want, you can look through the code and verify that this performs multiplication of two complex numbers. Hopefully you've seen that before in math class. If not, you can take my word for it, or you can research it on the web. Now the other times operator is between a complex number and a double. I'm going to steal its calculation code as well from our old multiply by method, and then make the same replacement. So this becomes me, and x is still x. So that's our multiplication operator. Next we're going to do subtraction, and that's pretty similar to addition, so I'm going to steal the addition code again, change the operator to minus, and then just update the calculation code a little bit. When you subtract two complex numbers, you subtract their real parts, and then you subtract their imaginary parts. So that's all we need to do. And you can verify that that's the same as down here in our old subtract from method. Similarly, when we're subtracting a double from a complex number, we subtract the double from the real part, and there is no imaginary part here for the double to subtract out. So that's all we have left there. Now there's one more thing, one more overloaded operator I want to create here. I want to overload the unary minus operator so I can make a negative complex number. And you'll see why I want to do that in a little bit. So I'll make public static, and this is going to return a complex number, operator minus, and in here we have one parameter this time, a complex number which we're calling me. The fact that this only has one parameter and this has two is the way that C# can tell the difference between the binary minus operator where you're saying A minus B and the unary operator where you're just saying negative A. So how do we take the negative of a complex number? It's pretty simple. We just take the negative of the real and imaginary parts. So we'll say return new complex number minus me.real and then minus me.imaginary. So that one's pretty simple. All right, now let's go take a look at the main forms code. What it does is it creates complex numbers from the values in the text boxes on the form. Let me show you the form real quickly so you can remember how it works. So you enter values in these text boxes, and it converts them into complex numbers, and then it performs some calculations on them. Well, we got rid of these add to, subtract from, and so on methods, so we need to replace those with our new overloaded operators. So here, to calculate a plus b, we simply say a plus b. It's much more intuitive than the old version. For a minus b, we say a minus b. Instead of doing subtract from and putting b on the left, we can now do this much more intuitive version. And here we have a times b. Oops, what happened? A times b. Okay, so that's all great when we have two complex numbers. Now let's go down below. Here we're doing some calculations with a complex number and a real number. So here we want x plus b, x minus b, and x times b. Stop that. X times b. Okay, so what's the problem? The Visual Studio doesn't like this. If we float over it, it says operator plus cannot be applied to operands of type double and complex number. Well, we overloaded complex number plus double, but we didn't overload double plus complex number. And if you want both versions, if you want to be able to put either kind of number on both sides of the plus or minus sign, we need to overload both operators. So let's go back in here and find our operators again and add that version. So here are our plus operators. Let me copy this one, and we'll create a version that puts the double on the left side of the plus sign. Now we could use the same code here. This will give us the correct result. We got me.real plus x and then me.imaginary. But we already have another method that does, or another operator that does exactly this. So let's use that instead. That will reduce the duplicated code and make it easier to maintain this. So for x plus me, I'm going to return me plus x. So it's as simple as that. The plus operator is just as simple. So let me copy this down here. I'm going to switch the order of the two arguments. And instead of duplicating the code, I'm going to say return me times x. Now the subtraction operator is a little bit different because a minus b is not the same as b minus a. So we need to change this around a little bit. And we could flip this around. This would be x minus me.real, and this would be minus me.imaginary. But we can also implement this using operators we've already defined. So I'm going to do that version. I'm going to say x minus me is the same as minus me plus x. Okay, that's why I overloaded the unary minus operator, so I could say minus me. If I take this out, let me just comment it out for a moment, you'll see that it doesn't know how to create a negative of me. All right, so let's go back over here to the forms code and make sure now it understands x plus b, x minus b, and x times b. Let's run the program and see if it works. So if I do the calculation here, it's taking these two complex numbers and calculating the results. And if I click this button, it's taking this real number and multiplying and combining it with this value b. So it's, for instance, 3 plus 2i, which would give us 6 plus 2i. So that's correct. So I guess the moral of this lesson, first, there's an exercise in how you do these operator overloads. And then also, to reduce duplicated code, you can use the existing operators that you've already created to produce new results. That way you can reuse them instead of having to write completely new code.